Okay, let's do the final example. So this is not in the textbook, this is from your slides. You have this example with hole. So basically, here what you have is, you have this, mainly you have this triangle, rectangle and right triangle here. And then you have this semicircle, sorry, quarter circle and the whole of semicircle, okay? And you are given the dimensions, 6 meter, 3 meter, this is 3 meter arc and 1 meter arc, okay, 1 meter radius, 3 meter radius, okay. And then question asks you to find the centroid, okay, again, find the centroid. Okay, though actually is given in the question in your slide, you can check that. It's not mentioned anywhere about I mean you have to define your XY system, okay, the coordinate, because ultimately you will use the XY coordinate system. So for instance, you say that this is X axis, okay, you can have this X axis as well, no problem, but your X coordinate will be negative again, so don't complicate yourself, that's the idea, okay. I know if you do this X, then everything will be negative, the coordinates of the Y, not X, the Y, okay. And then now you can choose, now for Y, you can choose whether you want to put here, the Y axis, you can put here, or you can put here if you want, or you can put here even. If you put here, then everything will be positive X, right? And I mean, it doesn't matter, but let's say, let's try to put here, this is Y, is it okay? Okay, let's put this as Y. Is it okay? I mean, you can put here if you want, no problem. But in this case, let's put here. No, actually, in your example. I mean, the question put Y here. If the question put Y here, then just put that one. Okay. All right. So, how many bodies that you have? I mean, you can section into smaller bodies. A is a rectangle. This is B, triangle. You have C, is a quarter circle, right? And then you have this D, which is a whole of semicircle. This semicircle is a whole. Okay. So this is 6. How much is this? Can you tell me how much is this? This is 3, right? Why? Because this is 3. This is 3 meter radius. Of course, this will be 3. This one will be 3. Okay, because this is a quarter circle. So this is 3, this is 3. So this is 3, this is 3. It's okay. This is 3 meters. Okay, it's not given in the question, so you have to figure this out. Okay. So to find the centroid, you need to do the X bar, Y bar, and Z bar. So for instance, X bar is summation of X tilde BA over summation of A, or not BA, just A. Okay? Because you have the area, you can find the area here. Right? So you have to find this. Make a table. This body, you can simplify them into smaller shapes, simpler shapes, which are this 4, A, B, C, and D. So you have the first one, which is let's say you want to say segment or shape or whatever. Segment, okay. You have A, you have B, you have C, and you have D. Okay. A is rectangle, rectangle, yes. B is triangle, right triangle. C is the quarter circle with 3 meter radius, and D is a semicircle with a 1 meter radius, and it is a whole. Okay, this D. So you can have your area. Okay, meter cube, meter squared. For your segment, A is 6 times 3, right? 6 times 3, 18 meter squared. Okay, for B, it is half times 3 times 3. So half times 3 times 3, which is 4.5. It's okay. And for C is what? What's the equation for this quarter circle? The area of the circle is pi r squared, isn't it? So quarter of that will be 1 over 4 pi r squared, isn't it? Pi r squared is the area of the whole full circle. This is quarter, so 1 over 4. 1 over 4 times pi over there. So you have this 9 over 4, 2.25 pi. Okay? You can multiply by 3.142 or whatever, it's up to you. And how about D? D is a half circle. Not half circle, semicircle. So pi 1 squared 1 over 2, isn't it? Half pi r squared. So you got 0.5 pi minus, okay, here it is minus 0.5 pi. Why minus? Why minus? Because it is a negative area. There is no area, okay? The rest, they are real area. You have real area, real body. Here actually it is a hole, so you need to have minus area or minus volume. I mean, depends. But here is area, so it is minus area. It's okay. Next, you have to define your x tilde, y tilde, and xy only. X tilde and y tilde, okay? So for your triangle, your x tilde, x is this, x equal to 0, right? Because you define this x and this is y, so 0, 0 is at this point. So from here to the center, so for triangle, rectangle. For rectangle, the centroid will be in the middle, right? Half of this, half of that. So this is the centroid. Okay? So how much is this? The x will be 3, positive 3, and the y will be 1.5, half of 3, 1.5. Okay? And both are positive coordinates. For B, okay, like we discussed before, for triangle, you have this 1 over 3 from the big side and 1 over 3 from the other side, from the big side, okay? 1 over 3 to over 3, 1 over 3 to over 3, okay? So 1 over 3 of 3 is 1, isn't it? So centroid is somewhere here. Okay, here. Okay, so this is 1 over 3 from this side, and this is 1 over 3 from this side. Okay? So 1 over 3 of 3 is 1. So 1 plus 6 is 7, isn't it? So x is 7. Again, 1 over 3, 1/3 of 3 is 1. Okay, this is 1. So plus 6 to have 7, because this is coordinate. What we are doing here is the coordinate. Okay? And how about y? Y is 1 over 3 from 3, which is 1. So it is 1. Okay? Because here is y equals 0, so it is y equals to 1. Y equals to 1. It's okay. Okay, for this one, C and D, okay, let me show you something first. For C and D, again, this can be found in your textbook, the back cover of your textbook. Okay, if it is a circle, full circle, the centroid will be in the middle. It's okay. I mean, the center of the circle is the centroid itself. It's clear, isn't it? That's very logical. But how about if you have this is the centroid. But how about if you have half of the circle, which means that you have semicircle? So what happened? If you have semicircle, will the centroid remains at the center of the circle, of the semicircle? The answer is no. It can be, right? You can see that the mass or the volume or the area has shifted, isn't it? Have shifted somewhere. So it's not here anymore. It's given in the book, which is 4r/3 pi from this. Okay, so the centroid is now here. Okay, 4 times radius. Okay, 4 times radius divided by 3 pi. Okay, this is the equation. So it just depends on your r. What is the value of your r? Okay, so it is from centroid to the DC. From the center of the circle of the semicircle to the centroid, it is 4r/3 pi. But it is still, just above the center, right? Now, if you have quarter circle, what happens with the radius r? Okay, this is radius r. So your centroid of this quarter circle, it will be 4r/3 pi, and this is 4r/3. Is it okay? Now it is shifted even more. Previously it was in the middle, but in the middle of in the middle of this is of symmetry. Now if you take out half of another half or quarter of the original circle, so you just left with this, and then the centroid will shift 4/3 pi. Sorry, 4r/3 pi, right? Okay. If it's unclear, then you go back to the textbook and look at the diagram correctly, clearly. So for DC, this is what? This is a quarter circle. So the centroid of this is 4/3 pi from the center here. It's center. So it is somewhere here, for instance, when it doesn't. So this is 4r/3 pi. It's very hard to even say it. Okay, and this is 4r/3 pi. Can you understand that? So this is quarter circle, 4r/3 pi, and 4. This 4r/3 pi, 4r/3 pi, and 4r/3 pi from the center. It's okay. So how much is the x till there? It is 4r/3 pi. So it is 4 times r, which is 3 meter over 3 pi, isn't it? And it's minus. It's okay. Why minus? Because x0, again, we go back to the original geometry. X0, this is x minus, isn't it? And y, how about y? Y is 4r/3 pi. The r is 3 meter, right? Okay, how about d? Regarding d, the x is 0. Why x0? X is in the middle. X is in the center here. The centroid of this semicircle is this, right? So this. So this is the 0, 0. So x is 0. Okay. But for y, then you have this 4r/3 pi. So 4 times r/3 pi, and it's positive because it goes up, right? Okay. Okay, what do you want to do? Okay, so we go to summation of A. Okay, let's do summation of A first. 18 plus 4.5 plus 2.25 pi plus, sorry, minus 0.5 pi. So you got 27.998, for instance. 27.998 meters squared. Okay. So let's have the next table, x tilde a and summation of y tilde a. Okay. You have a, b, c, d. So x tilde a, 3 times 18, it is 54, right? 54. Y tilde a is 1.5 times 18, 27. Okay. And this x tilde a for b is 7 times 4.5, 7 times 4.5, 31.5. And 1 times y tilde a, 1 times 4.5, you get 4.5. Okay. And c is this times this, which is minus 4 times 3 divided by 3. So okay, so you guys can cancel them out. Okay, 4 over pi minus 4 over pi times 2.25 pi. So the pi will be cancelled out actually. So it is minus 9. And this 4 over pi times this. So actually you can cancel the pi. 4 times 2.25, which is 9. Okay. And then for d, 0 times this is 0. And then for y, it is 4 over 3 times pi will be cancelled, minus 0.5. So it is minus 0.667. It's okay. Yes, so okay. So we can solve them now. Accidentally deleted the summation of A. What was the summation of A? It's around 28, isn't it? 57 point something, so 28. Okay. So to find your x bar, the exponent of the centroid, x bar equals to summation of x tilde A over summation of A. So summation of x tilde A, or we have not found this. Summation of x tilde A, okay, you sum them up. 54 plus 31.5 minus 9. So you got 76.5. And for summation of y tilde A, okay, you sum these 4 up. So 27 plus 4.5 plus 9 minus 0.6667. So you got 39.83. 39.83. Right? So this one, x bar, 76.5 over the area, which is 28. Okay, you hit the calculator. 6.5 divided by 28. You got 2.73 meter, and y bar is summation of x tilde A, summation of A, which is 39.83 over 28. So you got 1.42. Okay, which means that it is somewhere around here, 6 to 2.7, right? 2.7, and this is 3. 1.4 will be around half of that, so somewhere here, isn't it? So this is your centroid, x bar, y bar. Okay, centroid for the whole, right?